Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ISRO's future plan for 2025. Basically what's going to happen in near term, so to say. So first big flagship mission is Gaganyaan. Now this puppy was basically approved by Indian government in December 2018 and budget for it was 10,000 crore. Now that number in useful terms for Western audience is $1.5 billion in USD, so to say, was allocated for this mission. Now the original timeline in 2018 was 2022. However, you must have known that something big bad happened, which was COVID, and then other stuff. Again, it's a government project and a rocket project, so timelines are what we call LOL. So that does happen. Now, human rated launch vehicle should be used, basically Mark 3 variant. So India has a very powerful heavy lift capable rocket, which you call GSLV Mark 3, basically geostationary launch vehicle Mark 3. Now, we use that so much that, and again, it was designed for geostationary, so it has a lot of oomph. And again, we found out, hey, we actually can use it for low Earth orbit also, for many other missions also. So they renamed it, but I'm going to always call that GSLV Mark 3. So it has an upgraded variant, which is human rated launch vehicle, which just have more redundancy, basically things that makes it far more safer for human system, so to say. That's why. And this capsule is designed in such a way that it should be able to sustain humans for a few days, aka 3 to 7 days. And the mission target is 3 to 7 days. I'm like, wait, why mission target is 3 to 7 days? Yes, you are talking about Indian Ocean and environment, atmosphere. So weather can cause your scenarios like you sent everything, but if the recovery site location became unsuitable, you may delay landing. So for that reason, you do want some buffer. Again, in an emergency, you can land it. It's just that recovery after landing would be very brutal. So that's why you always want a bit of a wiggle room. Now, what about astronauts? Now, these are 4 gentlemen. They are from Air Force. They are solid, best of the best that India has to offer, and they are ready to go at this point in time. Surprisingly, astronaut part is working flawlessly. That's not an issue. And at this point in time, timeline has been delayed again. It's supposed to happen in 2025, but it got delayed to 2026. So that's a bit of a delay. But again, if India achieves this, India will become in a very exclusive club which has people on space, so to say. Now here's the deal. This is the ironic part. There is 200 countries on this planet and only few of them have rockets, and ironically almost all of them are reaching a point where it's like, yeah, almost all can send people to space, all can send make a space station and run a space station. So it's like the differentiation is not there as it used to be. Like in the early days, there were only 2 players, Soviet Union and America. Soviet Union went poof, Russia got its leftover, so to say, and America, Russia, then it became China. Now India is reaching their point. It's like, yes, we have seriously. Any contender, you can say other countries are trying. EU specifically has a problem with excessive bureaucracy. They had awesome projects. This bureaucracy boomed them. And Japan is also slowly chipping away their capacity. So they are also gaining a lot. But again, if this happens by 2026, India will be in an exclusive club where only 4 countries will be there. So that's a good progress. Now, here's the deal. So far, India is only running on ancient rockets that are made in 1970s or 70s philosophy. So government realized this, and there is a new umbrella term, so to say, which we call next generation launch vehicle. Now, this is a whole project where they're like, you're supposed to build technologies that should allow you to build rockets that are next generation. So this puppy got started in September 2024. Most of the video that I'm talking about is September 2024. And the budget is 8,240 crores. That translates to $1 billion for this launch vehicle. Now, this is an 8-year plan because again, it's not one rocket. It's a technology platform, almost like an umbrella term. Next generation launch vehicles, it should be. It's a launch technology that you are building and then you attach it how you need it. So 8-year plan, and they're supposed to, at the end of the 8 years, should have completed 3 launches that would validate the system, and then they're like, go, final rocket is ready to go. Now, main aim is, this time they are stretching the wings, so to say. So it's 30 ton to low Earth orbit, which is a significant capacity. It's not minor. It's not like, yeah, it's significant. 30 ton is significant. There are only few rockets on the planet that can even claim that. So that's the target. So it's reaching what we call LEO heavy lift rocket class, so to say, and the only rocket that is like significantly better, or like in terms of tonnage, yes, Falcon Heavy can do that, but problem is the fairing is not huge. This has huge fairings. So that's there. And it's reusable from start. It's not like ULA where they're randomly trying, okay, what if we detach the back end of the rocket? It's like, yeah, no. Or even like even worse design of Aryan, where it's like, what if the solid boosters were liquid booster and then they came back? It's like, what if you did not had strap on? So this is a completely different puppy. This whole booster from day one is designed to be reusable. It's no longer like a bolted on reusable. No, it's designed to be reusable. And the primary enabler of that is Methalox engine, which is a very good judgment, because India has been sinking money into a system which we call a semi-cryogenic engine, SCE 200, and that puppy is ancient. How ancient? It was from Soviet Union. The blueprint is from Soviet Union. That's where India got that. Like, again, legally, properly, what we call technology transfer, but again, that was ancient. And we were pouring so much money into it. It's like basically using titanium to build a steam engine. It's unwise. So this time they're like, no, let's use methane liquid oxygen. Why? Well, if you have hydrogen, that gives you the most mileage. Basically, the specific impulse goes up. That's good. Penalty, that puppy has zero thrust. Basically, thrust-wise, it's very, very weak. And because your tanks are huge, insulations are huge, you may need way too much add-on to get it to orbit. For example, space shuttle. So hydrogen gives you very clean engines. Actually, it steam cleans it, but you have very weak thrust, so to say. Thrust-wise, it's like, not there. Now you have other end, that is kerosene, which is RP1, rocket propellant 1. Now you take crude oil, refine it, you get kerosene, then you refine the hell out of it, that you get jet propellant 1, then you refine jet propellant 1, you get rocket propellant 1. Now that rocket propellant 1 is expensive AF. It's so expensive that ISRO, when they wanted to use that, they're like, yeah, what if we subgrade it? Basically, ISRO saying it's a lower grade of RP1 to reduce cost, so to say. It's expensive. Again, you cannot reuse engines with that now. Like, isn't SpaceX doing it? Yes. And again, that's why they are not trying to do that again with Raptor. It's one of those things that you can force it. It's not recommended. Why? It makes coke. When you heat basically RP1, it could create chains, long molecular chains of carbon that is very sooty and very sticky. And it takes a white rocket, makes it into a black rocket. On top of that, that's just a cosmetic. Yeah, it destroys the turbines and all that. So it's not recommended for a reusable engine. So, but again, then why do people love it? It has thrust like there is no tomorrow. That's the sole reason why Saturn V can get out of the launch pad. It's like, I got this. It has a lot of dirt, it has a lot of poor specific impulse, but in terms of thrust, it's like shut up, take money. If thrust-wise, there is no competition. So you have thrust, you have efficiency. But what if you need something in between? Methane is a very good candidate. Benefit, we transport it anyway because it's what I call LNG, liquefied natural gas. So it's all, the ecosystem is already there. You do not have to do too much refinement and all that. So that's the good part. And again, it does not create coke. It does not have long hydrocarbon chains that can become sticky or gooey. Engines are clean, super usable. So instead of launching a white rocket, the white rocket will come back. It will not become black. And again, the gunk will pile up on the engine will be also less. So instead of trying to reach 20 reuse with Merlin engine, they can easily exceed 50 reuse with Raptor engine because of the fuel cycle. Same is here. And this puppy has my personal favorite. This has 3-stage. I like, why is that a good thing? Well, 2-stage rocket is more than good enough for low Earth orbit. But the moment you want to go into what we call high energy orbits or anything you need to put deep into the space, for example, Moon, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, you need a bit more oomph. Yeah, you run out of that oomph with 2-stage. But if you have a 3rd stage, even with basically less payload, you will get a lot more delta V. So it's a very wise way of doing it. You can actually launch something in space shuttle, which is just 2-stage to orbit. Actually, 1 stage, you deploy it and have that stage acting as a 3rd stage and heat. You can do very, very deep space mission with that. So having a 3rd stage, it's a really good thing. Now, as of now, I do not know whether they are planning to have 2-stage with a 3rd option or like it's going to be complete 3-stage stack. Because again, you have 2 options if done correctly. You can have like, hey, if you do not need that, we not build a stage, saves money, efficient. And if you need, hey, we need some deep space mission or very high delta V, you plonk that puppy on. That's up to you. So I'm not sure about that part, but it's a very good add-on. Because again, 3rd stage will give you far more delta V than no matter what you do on the bottom. No matter what you do on the bottom, like with strap-on booster or whatever have you, it will be always better to have a 3rd stage. And I have no idea who the heck came up with the idea of putting strap-on in a reusable booster, but they did. So Again, it's almost like India is like, but what if we stay to 1970s technologies? Like, no, do not use strap-ons. It's not a good idea. Like in terms of economics, physics like says engineering is like okay with it. Economics is like you bankrupt. Ask ULA. So 3-stage, 9-engine will be on the booster, and strap-ons for some reason. I think that's needed for that 30-ton to low Earth orbit. And they have a plan, very weird plan, where they're gonna take this booster and they're gonna use it as passenger system, meaning it's gonna be exactly like how we have New Shepard rocket. Actually, it should be more powerful than New Shepard, but that's the whole point. You're gonna have a capsule you're gonna have people, and people are gonna go yee for 200 to 300 seconds, and then they're gonna come down. And it should allow to have another revenue stream with the booster. So that's interesting. That's in there. That's in the plan, so to say. So next generation launch vehicle, basically, and the rocket that you are seeing here is Surya rocket. That's why I said next generation launch vehicle is a technology integration, so to say, for 8 years. It's like develop these technologies in 8 years, have a rocket for it, most likely Surya, and then go YOLO on it. So this is the next flagship project. Now we come to another thing, that is a Bharatiya Antariksha station. Now the first 2 words are Hindi. I do not know why the heck they use station there. There should be some Hindi word for that. But Bharatiya Antariksha Station. Now BAS-1, this is government approved in September 2024, and this got 11,170 crores, and that translates to $1.33 billion. So that's a lot of money. Now here's the deal. The first module will be launched in 2028 with GSLV Mark III, the rocket that we already have. Now BAS-1, basically the first module, it will be a self-contained system under 8 ton. Now, of course, penalty of that is trying to make everything inside a 8-ton system. It's like, yeah, it's not going to have a very long duration life support, but it's a good starting point. And again, it will allow India to have a foothold in space where they can cycle missions on and off. Because many times the capsule that you are launching people on, it has more than enough horsepower. It just does not have space for people to do. So even if you can have a remote electronics there, a lot of things can be done if you just have a place to put things, place to cycle people in and out from. So a space station is a desirable system, even if it's just one module. So there is a lot of benefit of that. Now 8 ton is just the starting module, and it will be the core of this whole payload system, base module, so to say. Now the target point is that it's going to hold a crew for 15 days. So that's just one block. So 15 days, that's what they are aiming for. And after that, next generation launch vehicle should be ready, and they will use that, because the second parts, basically part 2, part 3, part 4, those puppies are heavy. They can stretch up to 20 tons. So right now we do not have anything in our portfolio to launch that. So the idea is you get the one, you get the everything sorted, and by that time we are done with this basically block 1, we should be in a position to launch block 2, bigger, heavier, more capable module. So basically base module will be added with core module, science module, lab module, CBM module, all those things will be added. And it's built with new technologies. One of my personal favorite technology is roll-out solar array, because you have to understand, when you're talking about something big like this, the weird limitation is power. We want to do so much, we just don't have the power. So how do you get the power? Well, solar panels. Now, problem with traditional style of solar panels, they are very bulky. The panels are very bulky because they have to have hinge. That high hinge has to survive launch vibrations and somehow properly deploy in 0G. Again, you may think it's not that difficult. Again, we have been doing it. It's just tedious. It's expensive. It's bulky. What if you could have a simple system? Roll out solar panels, and again, it has been tested by NASA, has been deployed on ISS, so it's actual in-orbit use. So it's a good next generation technology, will be the backbone of these things. So that's a very good long-term solution. We will not be power limited. Then we come to Chandrayaan 4. Now this puppy is got green light on September 2024. Again, government just greenlit a lot of things, and it's getting 2,104 crores. That translates to $253 million. Not that much, like almost a flop movie from Marvel. So that kind of price. And it's going to do a sample return mission. So it's not only going to go and go, it's going to go, it's going to pull things out of there. So aim is to put India in a position where we have regolith in our soil. Regolith is very, very precious at this point in time. Only few countries have it. India will become into that elite club. Again, there are only a few countries I can compare with. Like technically I can say, yeah, 190 country does not have it. It's just like they do not even have rockets. So this mission is very, audacious because it has to do multiple things. First, it needs orbital docking. They're gonna launch two rockets, GSLV and PSLV, one a small puppy, one a big puppy, and they're gonna make love in the orbit. And it's like, why? Well, we do not have next generation launch vehicle yet. So this is the next best thing. You dock it. Basically, this is one module, this is second module, and you dock them in low Earth orbit. Then it does, basically after that, it's exactly how Saturn V did. You have a lunar injection burn, then you have a decel burn, then you get trapped by moon's gravity, then you detach this puppy land, this puppy cranes it up, dumps it into ascend module yeets, ascend module goes and dumps the data into transfer module, basically the actual capsule, it eats it, dumps it into re-entry module. This puppy fires back it to low Earth orbit. Then from low Earth orbit, this figures out the trajectory and yeet it. And this thing's supposed to land in Indian Ocean. Now, Indian Ocean is huge, and Indian Navy has to figure it out. Basically, ISRO and Navy will work it together. It's like which is the most optimum path, weather recovery, because again, you do not want this capsule to be lost. It's expensive. So, not like a failed movie. So that's the aim point of it. So it's almost like Saturn V Mini's version. So that's the aim of it. It's a very complex, and again, once we can sort two independent payload docking with each other in orbit, that's a very significant upgrade. Because yes, dear, you can try to make a super heavy rocket or like Starship or even like Starship 500 or whatever have you. There is an upper limit how much you can actually do. But if you can sort the docking part, the things you can do even with limited technology becomes vast. Basically, you can do amazing things if you can have low Earth orbit docking reliably enough. So that's a very good thing, sorting out dockings. Now, what are the good and the bad? Well, the good are there are lot of core technologies that has been worked here that will allow future expansion rather than being the bottleneck. Because here's the deal, we can pour as much money as we have poured into semi-cryogenic engine 200, but it will never be competitive with a methane engine. It's like same thing. You built like 3D printed titanium, blah blah blah, steam engine versus stainless steel, nickel coated jet engine. Jet engine will be better. So same thing. This time I'm seeing a lot of foundational technology that is actually next gen. It's not like, back in the days of safety. No, this is a next gen technology. Like, it's a surprisingly bold move to rely on rollout solar panel on a human rated system. That's like, damn. And there is no fallback like ISS. So that's a big, audacious, long-term plan. Because again, it will not limit us from day one. It's like, oh, we built what Germany did with their fiber connection. They were not interested into optical. They thought like copper will win out, so they did not invest into it, and then oops. So this is not happening here, so I'm very happy with that. Rollout solar array is very good. Methalox engine is a very long-term commitment, and again LM470, again name could change. This puppy is supposed to be used, and again details are not clear. It's not gone through all the development of fire testing, so I cannot dive deep into it. But again, it's a good system. Even if it's a, let's say, Mark 1 engine, how exactly Raptor 1 versus Raptor 3, same thing can happen here. It's a very good long-term strategy. Chandrayaan 4, again, sorting out docking in low Earth orbit, that's a very awesome thing to do. And again, all the docking stages that we have to do, if we can crack it, that's like shut up, take money. Another aspect, building a 3-stage rocket, that's a very thought out plan. Where it's like, hey, we may not have the most tonnage, but we will able to yeet things into very high energy orbits. That's a good thing. However, one thing that I've always found the biggest weak link of ISRO is it has no focus on public relation. Now, like, does that really matter? Short answer, absolutely. Absolutely, it matters. There is a movie, Apollo 13, based on real event, the incident that happened with Apollo 13. Here's the deal, the Apollo 13 was going to the moon. That time, news anchors were making fun of Apollo missions because, again, there was no point of it, and they figured out very early on, it's like, yeah, Soviet Union is just lol. So people lost interest. They were making fun of it. And again, what happens to this puppy? Poofed. So be mindful, public interest is directly proportional to money, and that is directly fund or defund a mission. So if you public loses interest in things, it has penalty. It's not just like, who cares? Like, again, if Artemis mission does not have good documentation, it's like, what are we doing? If you're not transmitting the data and all that, why do you think NASA is pouring so much money into laser communication? It matters. Like, you will think, oh, it's just to allow us to do better deep space. Yeah, that's the benefit. The primary requirement is like, this time moon mission has to do with proper 4K. Again, even back then, they literally put so much effort into having the TV camera back in those days rather than just photo. There was a reason for that. So public relationship matters, and ISRO sucks in that department. Everything else, ISRO is awesome. There is no discussion about that. that and the fact that we are really stuck in 1970s. Other than that, everything is awesome. But they have to sort this public relationship part, because it has a serious scientist vibe to it, where people are like, oh, we are doing the science. It's like, people do not pay for science. People pay for entertainment. People pay for entertainment. Are you not entertained? No, we are not. Yes, the science is not like, they can say, like, I have seen director of ISRO is talking about like, hey, we have got all the good data and all that. It's like, you do not have launch footage. People will not be interested. And next time when Indian government has to pass the budget and they're gonna say, like, we are why are you depositing that much money? And again, what will people remember? Most people cannot, decipher the data. Oh, this is the spectral emission of Mars. We can't do that. But again, we can remember how the heck the rocket looked, and rocket looked like it was launched in 1970. Video footage is literally same. And again, that directly pisses people off. It's like, it's not important. If it's not a HD camera, it's not important. And again, while scientists will pay for it, they are not enough of them. You have to tax it, the whole tax base. That's why this is a very important thing. And that's why even a small rocket companies, they are making YouTube channel, they are actually doing interviews, they are spending time on getting public interest. If public is not interested, yeah, bad things happen. Again, fully built rocket. Like, rocket was like almost to a point where it's like, yeah, let's finish it up. Let's launch another mission. Yeeted. Fully built Saturn V. It's not a toy. It's like actual Saturn V. So let that be very clear. Science is not only for book. You have to understand. You have to get people interested into it. People have to be attracted to it. It's not, oh, we can do so much science with rovers rather than people. It's like, yeah, nobody gives a damn about rovers. People give a damn about human. Human matters. Again, you may be like, that's our limitation. That's absolutely true. But again, you have to work inside human constraint. It's compulsory. And this has another aspect of like, India is suffering from brain drain. A lot of our brightest generally eat from here and go into, well, every company you can name. I'm not even joking. Every company you can name, there will be Indians in there. A lot of them. Like, ludicrously large amount of them. Be it Blue Origin, be it SpaceX. Go YOLO on it. Trust me. You will be shocked how many Indians are there. Again, why don't we can stay in there? Again, first is the finance. The money is very tight. On top of that, yeah, they can't even proudly say, oh, I worked in the rover that was actually riding on the, lunar surface. That's an awesome thing. Try finding one photo of it from ISRO. One. We don't have good footage of it. In 2020, we do not have good footage of it. It is not even 1970s. So it matters. Public gets frustrated, distracted, or again, we have issues to worry about. So if you're not doing the PR right, it has penalty. Not only from the brain drains point of view, but also a budget point of view. People are like, okay, let's just cut the project. And I cannot blame them. It's like, hey, inflation is going. What is more important, inflation control or space program? Inflation control. And again, the budget is huge. So this was my presentation on basically ISRO's upcoming years. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me out. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.